of the United Nations Global Goals for Sustainable Development is to create sustainable cities and communities. In order to make our cities safe, inclusive, resilient, and sustainable, engineers work in a variety of ways to apply scientific knowledge to make our world a better place to live in. This includes ensuring access to clean drinking water, reducing adverse effects of natural disasters like earthquakes, and creating sustainable transportation systems by utilizing clean energy for better transportation options. Sustainability is an area that every single program in UBC Engineering addresses, and in this video you'll hear from 3 instructors and researchers from Chemical and Biological Engineering, Environmental Engineering, and Civil Engineering about just one of the many ways their program focuses on creating sustainable cities.
Globally, there are nearly 800 million people that lack access to clean and safe drinking water. Similarly, in Canada, even though we are living in a developed world, there are still 20% of our population, that roughly over 6 million people, do not have access to risk-free water. As part of my research, the focus is really to address that particular problem locally, so they don't have to worry about opening their tap or taking a bath at the end of the day. My name is Majid Mohseni, and I'm a professor here at the Department of Chemical and Biological Engineering. In my role at UBC, I am the director and supervisor of our research lab, which we call Sustainable Water Innovation and Research Laboratory. And in this lab, what we work on is treating water or developing innovative solutions that help to treat the water for human consumption. So in my lab, we have groups of graduate students and postdocs that are working on specific projects towards treatment of the water. They work on various projects, including development of the technologies, evaluating the quality of the water, and also assessing the efficiency and performance of those technologies in treating the water.
Hello, my name is Mertosh Motamedi, Earthquake Lab Manager. Welcome to Earthquake Engineering Research Facility of UBC. Here in this lab, we are interested to see the behavior of the structural components when we are testing. Let's go over there and I'll show you our facilities here. This is our Uniaxial shake table, which is a house-made shake table. The main idea for performing this test was to obtain the behavior of the structural components in this building and get the better solutions for retrofitting the weak buildings for school buildings in BC. I was born and living in a country, the potential for seismicity there was really high, the same as here in BC. So I got interested with earthquake engineering. And I thought that by being involved in structural engineering, I can provide safety for people. Now let's go and take a look into our multi-axial shake table. This is our multi-axial shake table, which is a unique table across Canada. And we usually use it for seismic certification tests on mechanical and electrical cabinets or equipment. We also can use it for testing structural components. I believe that diversity of the people and their skill in working in this lab is very important. Earthquake engineering is generally engaged with different areas. So we have to work with different people with different level of knowledge and experience and with the different backgrounds to have a wide variety of knowledge and experience.
Hi, I'm David Wilkinson, a professor and Canada Research Chair in Chemical and Biological Engineering. Our group works in the area of clean energy and clean water, 2 of the most important challenges that we face today. Did you know we will need to at least double the energy production by the middle of the century? The energy should come from clean, sustainable methods without affecting the environment or climate. We are looking for sustainable solutions that balance the environment and economic and social requirements. This is a big challenge, but it is what chemical engineers and engineers in general do. We are trying to tackle some of the world's biggest challenges and have an impact. In our electrochemical engineering work, we work with devices such as fuel cells, electrolyzers, and batteries, and in areas such as energy conversion, energy storage, catalysis, nanomaterials, and engineering design at different length scales. Today, we are focusing on batteries, which are critical for electrification of transportation. It is anticipated that the demand for batteries could rise by 2 orders of magnitude in the next 20 years. In our research in the Wilkinson Group, we look at aqueous or water-based batteries and non-aqueous lithium-type batteries. Research is done by senior research associates, graduate students, and undergraduate students just like you. You're going to have a small battery tour with Dr. Armin Bongnaktapur, a senior research associate in one of our labs at UBC. I hope you find it interesting.
Hi everybody, welcome to our battery research lab in the Clean Energy Research Center at UBC. My name is Arman, I am a research scientist who works here. I'll be giving you guys a quick tour of our lab and what it is that we do here. Let's look at some batteries that we work with and we test here in this lab. Here I have an example of a lithium-ion cell. So these lithium-ion cells were introduced by a Sony company in 1991, and they've been increasing their energy density and the power that they can deliver ever since, to a point that all electric cars are using them. So for instance, an average Tesla car would be using about 5,000 to 6,000 of these cells. So what we are interested to learn in this lab is what the failure modes of these batteries are and how we can extend their lifetime. So to do that, we will need to put the cell inside a test board. So this is a precision test board that allows us to monitor and measure both voltage and current and also the battery internal resistance during cycling. Dr. Beijing Fang is another research scientist in the group. He's preparing some electrodes using materials that we have developed in the lab to be tested in the battery. So he has coated some metal foils, and now he will be spinning under a vacuum to get uniform deposition. In order to test the materials that we develop in our lab, we work with coin cells. So here I'm holding a simple coin cell. The coin cell has to be made inside a glove box where we monitor humidity and oxygen. Inside this box we have inert argon gas. We also reduce the humidity. Inside the glove box you can see it's quite busy, but here our PhD candidate Bing-Xin Zhou is putting a coin cell together. So you guys can see she has lined up a whole bunch of components, and then once everything is inside the coin cell, we will crimp it. So crimping machine is that blue machine you see there. Alright, so the coin cell goes inside and it will get crimped, and we made one of those crimped coin cells which I showed you earlier. So this was a quick tour of our battery lab and the kind of things that we do here. I hope you enjoyed our quick tour and stay well.